All right, in just the next couple of minutes, we are going to demystify a concept that's, well, secretly running your digital life, the stack. Now, I know it might sound super technical, but trust me, the main idea is as simple as stacking plates. So let's dive right in.
Okay, so let me throw a question at you. What in the world could your browser's back button possibly have in common with a pile of dinner plates? It sounds like a weird riddle, right? But the answer is the key to this whole thing.
Believe it or not, this whole complex-sounding computer science idea can be explained with something you find in your kitchen cabinet. So let's start right there with a stack of plates to really get the main idea down.
Okay, so here's the official textbook definition. A stack is basically a list where you can only add or remove things from one spot, the very top. Think about it. You'd never try to pull a plate out from the bottom of the stack, right? That would be a total disaster. You always take from the top. It's like a Pez dispenser for data.
And that simple rule has a very important name: last in, first out. You'll often see it shortened to LIFO. It just means the last thing you put in is the very first thing you take out. The last plate you put on the stack is always the first one you grab for dinner. This one principle is everything.
So, how do we actually talk to a stack in the world of programming? Well, there are two key actions, two special words you're going to hear all the time: push and pop.
And you can see it perfectly here. When you add a new item to the top of the stack, that's called a push. And when you take that top item off, that's a pop. It really is that simple. You push an item on, and you pop an item off.
So let's just boil it down. Push is how you insert something. Pop is how you delete something. That's it. Those are the two main commands that control the whole thing. And they always happen right at the top.
All right, so the plate analogy is great and all, but what does this actually look like when you're writing code? Let's bridge that gap now, from the idea of a stack to how a developer would actually use one. We'll use the Java programming language as our example.
And here's the cool part. Programmers don't have to build this thing from scratch every single time. Languages like Java come with a stack class already built in. Of course, it's based on that LIFO principle. It has the push and pop commands ready to go, and it even includes a few other handy tools for things like searching the stack or just peeking at the top item.
And honestly, getting started could not be easier. A programmer literally just has to import the tool they need and then create a new one with a single line of code. Boom. Just like that, you have a working stack ready for your data.
Okay, enough talk. Theory is one thing, but seeing it in action is where it really clicks. Let's walk through some actual code to see all these ideas of pushing and popping come to life.
So in this first chunk of code, we've got a function that's just running a little loop. It pushes the number 0, then 1, then 2, 3, and finally 4 onto our stack. So quick quiz. After this runs, what number is sitting right on top? Yep, it's 4, because it was the very last one we put in. Next up, we call another function to pop all those elements right back off. And because of LIFO, last in, first out, what's the first number to come off? You guessed it, 4. Then 3, then 2. It's the exact reverse order they went in. See how that works? Perfect. But wait, there's more. The Java stack also has some other handy tricks up its sleeve, like the search function. You just give it the stack and the item you're looking for, and it'll tell you where it is.
And this right here, this is basically the main control panel for our little program. You can see how it calls all the other functions. It creates the stack, it tells it to push the items on, then it tells it to pop them off, and finally, it runs that search.
So what do we get when we run it? The program spits out this message. It found the number 2 at position 3. Now you might be thinking, wait, why position 3? Well, remember, the stack counts from the top. The top element, number 4, is at position 1. The one under it, number 3, is at position 2. And that means our number 2 is at position 3. The code works exactly like it's supposed to. Okay, so we've talked about plates, we've looked at the official definition, we've even walked through some real code. Let's take a step back and answer the big question. Why should we even care about this?
It really all comes down to this. A stack is just a super simple but incredibly powerful tool for managing anything where the order of operations really matters. Anytime you need to handle things in that last in, first out way, the stack is the perfect tool for the job.
And that brings us right back to where we started. Your browser's back button? A perfect example of a stack. Every new website you visit gets pushed onto the top. When you hit back, you pop that last site off to see the one you were on before. Same goes for the undo function in a text editor. So I'll leave you with this. Now that you know the pattern, where else do you see it in your daily life?
I bet you'll start seeing stacks everywhere. Thanks for tuning in.